let's we start for today class. Firstly, I will introduce myself. My name is Ankit Jain, and I am BTech from Civil, MTech from Civil, and PhD from Civil. I belongs to Bhopal, Madhya Pradesh. That means central part of the India, and you are from eastern part of the India. But it doesn't depends on it. I am belongs to center part of India, and you are belongs to eastern part of the India. But all over we are Indians, and we never be compromise any integrity of India. Am I right? So in this particular session, in this particular class, we always we will discuss in front of you. I will discuss in front of you strength of material. That means solid mechanics, you can say. So in this particular class, firstly, I will congratulate to you for Happy Holi. It's a great and joyful and colorful festival in India. So, my dear friends, let's we start today class. Let's we start for today class. If I am talking about strength of material, that means SOM. The short form is SOM. Or sometimes it is also known as solid mechanics. Am I right? Sometimes it is also known as solid mechanics. If I am not wrong. So, my dear friend, the condition is this. Now, see here what actually I will discuss. Firstly, I am introduced here the part of the syllabus. Firstly, I will discuss the part of the syllabus. So, if I am talking about the syllabus for your exam point of view, so now see here, please. Just wait. So, the first, the syllabus which is mentioned, the first is elastic constant. Another is stress. The first is elastic constant. Another is stress. Another is plane stress. Next is Mohr circle. For stress, not strain, only for stress. Mohr circle for stress. Next is strain. Next I will discuss. Strain. Next, plane strain. Next, Mohr circle for strain. Next I will discuss, it is combined stress. That means bending plus torsion. Both are act simultaneously. Or we can say the torsion will act on a shaft along with bending, or bending will acting on a beam along with torsion, like this. So next I will discuss here combined stress, then elastic theories of failure. Elastic theories of failure. Next, simple bending. Next I will discuss, it is shear. next torsion, shear, next torsion, next shear and torsion for circular and rectangle section, for circular, rectangle, for circular, rectangle and simple members, So this is our syllabus. This is our syllabus. So the first unit is elastic constant, another is stress, plane stress, Mohr circle of stress, strain, plane strain, Mohr circle for strain. Next is combined stress, elastic theories of failure, simple bending, shear. This is shear stress actually. This is shear stress. Next I will discuss. This is torsion for circular, rectangular and simple members. But my dear friends, please remember one point. Various points are to be there which is not mentioned in our syllabus, but these topics are very, very important to understand, because if I am talking about simple bending, so this simple bending is not possible. This simple bending is not possible to understand without shear force diagram and bending moment diagram. Are you get my point? All the students, please give me an answer. You get my point? Various topics are not included in our syllabus directly, but some topics are very, very important to understand, because for example, if I am talking about simple bending, so simple bending is not possible to understand completely without shear force diagram and bending moment diagram. So it is mandatory to learn SFD and BMD also. Am I right? Suppose that if in this particular syllabus, properties of material is not included. If properties of material is not included, that is fine. But the major condition is this: if I am talking about stress, if I am talking about strain, then what is the application of the stress? What is the application of the strain? It is completely understood by the help of properties of material only. So some topics which are not included in this particular syllabus, but in this particular class or in this particular sessions, we covered those topics which we covered those topics which are not in, we covered those topics which are not covered in our syllabus also, because these topics are very, very important to understand these particular topics. Are you get my point, all the students? If there is any issue related to that, then give me answer. If you have any issue related to that, then please give me answer. Anybody else? Can we start? So, my dear friends, first unit I will discuss, that means introduction and basics. First unit I will discuss introduction and basics. If I am talking about introduction and basics, so now see here what actually I will discuss. The concern is that if I am talking about engineering, so we already know that engineering is the branch of science. Am I right? We are the branch of science, or the application part of the science. We are the branch of science, or we can say we are the application part of the science. So before understanding the engineering mechanics, we will introduce in front of you engineering science. If I am talking about engineering science, so engineering science are dividing into a three part. If I'm talking about the engineering science, so engineering science is dividing into a three part. The first is properties of material. The first is solid mechanics. Another is, the first is solid mechanics. Another is fluid mechanics. The first is solid mechanics. Another is fluid mechanics. And next I will discuss, it is a properties of material. Next I will discuss, it is a properties of material. Properties of material. Properties of material. Are you getting my point? So if I am talking about engineering science, so engineering science, whole engineering science is dividing into a three-part, or dividing into a three-part. The first is solid mechanics, another is fluid mechanics, another is properties of material. So firstly, it is very important to understand what do you mean about mechanics. If I'm talking about mechanics, so in simple word we can say, if I'm talking about mechanics here, so in simple word we can say, if I am talking about mechanics, so in simple word we can say, to study of force on a body, it is called mechanics. To study of forces on a body is called mechanics. If you are applying a force on a solid body and studies those forces, then it is a part of solid mechanics. If you are applying a force on a fluid body, and study of forces, study of those forces which you are applying on a fluid, it is a part of the fluid mechanics. Am I right? So mechanics that means to study of forces on a body. To study of forces on a body. So my dear friend, mechanics that means to study of forces. To study of forces on a body. To study of forces on a body, it is called mechanics. To study of forces on a body, it is called mechanics. It is called mechanics. So simple word we can say, to study of forces on a body is called mechanics. If I am talking about solid mechanics, that means study of forces on a solid body. If I am talking about fluid mechanics, that means study of study of forces on a fluid body. Am I right? Similarly, if I am talking about properties of material, so these are the different field to know the property of each and every material, or to know the different properties for each and every material. My dear friend, if I am talking about solid mechanics, so so in solid mechanics, that means to study of forces on a solid body, there are two subjects. There are two subjects under this category. So my dear friend, the first subject is engineering mechanics. The first subject is engineering mechanics. And the another subject is strength of material. So the question is this, why you are teach two subjects under the solid mechanics? If I am talking about fluid mechanics is a single subject, no, it's a particular subject. But if I am talking about solid mechanics, so there will be a, if I am interested to analyze the forces on a solid body, then required a two subject. The first is engineering mechanics, strength of material. But if I am interested to analyze the forces on a fluid body, only fluid mechanics is sufficient. It is a single subject. So why there will be a two subject and there will be a single subject? What is the reason behind this? Because the solid body are of two types. Solid bodies are also is in two types. The first is rigid type of solid body. Another is deformable type of solid body. If you are applying a force on a rigid type of solid body and analyze those forces, then these type of rigid type of solid body is analyzed under engineering mechanics. So engineering mechanics is valid only for rigid body. Engineering mechanics is valid for rigid body. But if I am talking about the strength of material, so this subject is valid for deformable body. Deformable, that means, so I will say this subject is valid for deformable body. This subject is valid for deformable body. The question is deformable, that means. So deformable, that means if you are applying a force on a body, after application of force, the body will get deformed. Am I right? All the students are get my point. If I am talking about deformable body, that means if you are applying a force on the particular body, after application of force, the body will get deformed. Am I right? Body will get deformed. Suppose that, for example, if I am considering this is a body, I will applying a force on this particular body, tensile force or compressive force or bending, whichever force if you are applying on this particular body. If you are applying a compressive force, tensile force, then the shape of the body will not change. Body will never be elongate, will never be compressed. Am I right? So this type of body is considered as a rigid body. But if I am talking about my cheek, so if I am applying a tensile force, here, if I am applying a tensile force on my cheek, then you can analyze, it will deform. Am I right? But still it is a solid now. Am I right? That means solid body is in two types. The first is rigid type of solid body, another is deformable type of solid body. My dear friends, suppose that, for example, I will considering a body here, and if I am talking about this particular body, we will considering a 2 point. The first point is there, another point is here, and the distance between point 1 and point 2 is considered as a L1. So L1 is the distance between point 1 and point 2. If I am talking about the L1, so L1 is the distance between point 1 and point 2. You are applying a force on this particular body. After application of force, if you are applying a force on this particular body, so if you are applying a force on this particular body, after application of force, the bodies look like this. Suppose that the bodies look like this. You again consider these same points on this particular body. This is point number 1. This is point number 2. Point number 1 and 2 are same on both the bodies. Hai? That means if I will considering a body, and 1 and 2 point I will considering on this particular body, and the distance between the point 1 and point 2 considered as a L1. You are applying a force on this particular body. After application of force, the distance between point 1 and point 2 I will say L2. So it is after application of force, the distance between same point is L2 in place of L1. You are measuring the distance L1 here, you are measuring the distance L2 here. If L1 is equal to L2, so if L1 is equal to L2, then this body is considered as a rigid body. If L1 is not equal to L2, that means before application of load and after application of load, the distance between 2 points are not same or not constant. That means the body will get deformed after application of force. That means if I am talking about L1 is not equal to L2, that means this body is considered as a deformable body. This body is considered as a deformable body. My dear friends, I will discuss. I already discussed in front of you. In strength of material, we will consider only for deformable bodies, because strength of material is valid for deformable body only. So write down the one statement here. In strength of material, we consider body. In strength of material, we consider body is deformable. Type. Body is deformable. That means if you are applying a force, after application of force, the body will get deformed. Please give me an answer. This statement is clear or not? Please give me an answer. This statement is become clear or not? Give me an answer, please. All these statements are clear or not? So, I think statement is become clear for each and every student. My dear friends, if I am talking about some basic points. Firstly, I am discussing in front of you some basic points. What do you mean about basic point? Now see here. So firstly, I will discuss what do you mean about stress. What do you mean about stress? Now the name of this chapter is Introduction and Basics. So in this particular chapter, I am introduced only a basic of these terms. That means what do you mean about stress only? How to calculate? This is not included in this particular chapter. It is included in third chapter. In this particular chapter, we introduce only a basic terms. That means what do you mean about stress? What do you mean about strain? Am I right? So if I am talking about stress, so it is an internal internal resisting force. It is internal resisting force per unit. It is internal resisting force per unit cross-sectional area. So if I am talking about stress is a internal resisting force. It is an internal resisting force per unit cross-sectional area. That means what do you mean about internal resisting? It is an internal resisting force per unit cross-section area. If I am write this particular definition in a mathematically format, then you can write stress is equal to internal resisting force upon cross-sectional area. Internal resisting force upon cross-sectional area. That means you can write here internal resisting force is P internal and cross-sectional area is A. So it is the value of stress. If I am talking about units, so the unit of force is in Newton. You already know that. The unit of force is in Newton, and the unit of cross-sectional area is in mm square. And the unit of the cross-section area is mm square. That means the unit of the stress is in Newton per mm square. The unit of the stress is Newton per mm square. And Newton per mm square also said to be a megapascal. So the unit is in Newton per mm square or megapascal. Are you get my point? So the unit of the stress is in Newton per mm square or megapascal. So my dear friend, if I am talking about the stress, suppose that I will considering the body here. I will considering the body and you are applying a force on this particular body. If you are applying an external force on this particular body, so this P is the external force. It's not an internal force. In general, we can say stress is force upon area, but practically this definition is wrong. Stress is an internal resisting force upon cross-section area, is not a force upon area. It's an internal resisting force. Now, what do you mean about internal resisting force? See here. So if you are applying, I will considering a body and you are applying an external force on this particular body. So P, that means it is an external force. This is external force. Suppose we consider A is the cross-sectional area of the bar. A is the cross-sectional area of the bar. Actually, if I am making a 3D bar, if you are making a 3D bar, so this is the cross-sectional area. I get my point. So I will considering A is the cross-sectional area of the bar. This is this cross-sectional area I will considering A. So suppose A is the cross-sectional area of the bar. I will considering A is the cross-sectional area of bar. It is cross-sectional area of bar. If A is the cross-sectional area of the bar, and if you are applying an external force P on this particular body, so after application of force P, this body will not fail. Why it is not fail? It is not failed because suppose I will cut a section and considering a body here. If you are applying an external force P on this body, particular body, so after application of force P, after application of external force P, After application of external force P, the body will not fail. The body will not fail. Why it is not fail? Because this body is internally developed, internally resist external force. That means the molecules of the body, if you are applying a P force on this particular body, then internal molecule resist these P force. So internal molecule resist the force resist by the internal molecules, it is called P internal. But yes, 99.99% cases P is equal to P internal. If you are applying a 20 kilonewton loading here and internal molecules resist 20 kilonewton load, then body will not fail. If internal molecules are not able to resist 20 kilonewton load, then body will get deformed or what will get failed. Am I right? So the condition is this. If I am talking about the stress. So stress is not an external force upon cross-section area, it's an internal force upon cross-section area. It is the value of stress. My dear friends, if anyone say, then what do you mean about external force upon cross-section area? So if you are consider external force upon cross-sectional area, so if you are considering external force upon cross-sectional area, so if you are considering external force upon cross-section area, then it is not stress, it is a pressure. This is said to be a pressure. This is said to be a pressure. If I am talking about external force, the external force upon cross-section area, it is called pressure. Are you get my point? All the students, please give me an answer. All the students, please give me an answer. Understand my point? What I can say, the external force upon cross-section area is the pressure. It is not a stress. Stress is only an internal resisting force upon cross-sectional area. If you are considering the external force upon cross-section area, then it is a pressure. It is not a stress. It is a pressure. It is not a stress. Yes, but the unit of the pressure and stress are same. If I am talking about the unit of external forces in Newton, and if you are talking about the cross-sectional area, so the cross-sectional area is in mm square, that means the unit of the pressure is also a Newton per mm square, or sometime known as megapascal. That means the unit of the stress and pressure are same. That means the unit of the stress and pressure are same. Are you get my point? The unit of the stress and pressure are same. But the stress is internal resisting force upon cross-section area. That means it is a resisting force. And this is the applied force. Are you get my point? So this is the basic difference between stress and strain. That means stress and pressure. My dear friends, now see here, please. If I am talking about the pressure, so if I'm talking about the pressure here, so pressure, that means external force upon cross-sectional, if I'm talking about the strain, So the strain is the ratio of change in dimension to the original dimension. If I'm talking about the strain here, so in general terms, we can say, it is the ratio of change in dimension to the original dimension. It is the ratio of change in dimensions to the, change in dimension to the original dimension. It is the ratio of change in dimension to the original dimension. It is the ratio of change in dimension to the original dimension. Now, see here, what do you mean about change in dimension? What do you mean about original dimension? See here, please. If you're interested to write in a mathematical format, then you can write here: strain is become equal to change in dimension to the original dimension. Change in dimension to the original dimension. It is the ratio of change in dimension to the original dimension. So strain is the ratio of change in dimension to the original dimension. It's a very simple. If I am talking about the strain, then it is the ratio of change in dimensions to the original dimension. So my dear friends, now see here please what actually I will discuss. Suppose that I again considering a body here. And initial length of the body is become L. So L is the length of the body I will considering. So L is the length of the body. I will considering capital L is the length of the body. You are applying a force on this particular body. If you are applying a force on this particular body, now body will get deformed because in whole strength of material we consider the body is deformable. It is not a rigid type of body. We consider the body is become deformable type of body. So if you are applying an external force on this particular body, so after application of this external force, the body will get deformed. And the suppose that this P force is tensile in nature. So due to tensile force, the body will get elongate, na. Due to this tensile force, the body will get elongate. We already know that the body will get elongate. If the body will get elongate, then the length will be increased by delta L. That means the total length of the particular body is L plus delta L. After elongation, the length of the body is L plus delta L. So my dear friends, if I am talking about the strain here, so we already know that if I am talking about the strain here, it is the ratio of change in dimension to the original dimension. So the change in dimension is become delta L and the original dimension is become L. Am I right? So if I am talking about the strain, so strain is the ratio of change in dimension. So change in dimension is delta L and original dimension is become L. It is the value of strain. We already know that. If I am talking about delta L, that means change in dimension. Change is also observed is in mm. And original length of the member is also mm. If you are interested, then cancel out mm to mm. If you are cancel out mm to mm, that means strain is a unitless quantity. There is no unit of strain. Strain is a unitless quantity. There is no unit of strain. Strain is a unitless quantity. Are you get my point? But the unit of the stress is Newton per mm square or megapascal. But strain is a unitless quantity. Strain is a unitless quantity. So I will say strain is a unitless quantity. My dear friends. But if I am talking about the unit of stress, the unit of stress is Newton per mm square or megapascal. Unit of pressure is also a Newton per mm square or megapascal, but the unit of strain is unitless. That means strain is a unitless quantity. It is there is no unit of strain. My dear friends, now see here what actually I will discuss. What actually I will discuss here? See, if anyone talking about which come first, whose come first, stress come first or strain come first in the life? Whose come first? Stress come first or strain come first? The answer is, one student is giving me an answer, stress come first. Okay. Another? Please give me an answer for each and every student. Which quantity come first after application of loading? Stress will come first or strain will come first? Please give me an answer. Strain will come first or stress will come first? The most of the students are giving me an answer, stress will come first. No, it's wrong. If you are applying a force on a particular body, after application of force, the body will get deformed. to resisting these deformation, internal resisting force is to be developed. Are you get my point? To prevent this deformation, to resist this deformation, internal resisting force will develop. If body is not tends to be deformed, then no stress will develop here. If body is not tends to be deformed, then no internal resisting forces develop, or if there is no internal resisting forces to be developed, then no stress is to be developed. Are you get my point? Suppose that if I will considering a rigid body, if you are applying a force on a rigid body, after application of force, the body will not get deformed. That means no strain is to be developed. So if there is no change, if there is no stress is to be developed, then no internal resisting force is to be developed here. That means no stress is to be developed. If you are considering a deformable type of body, if you are applying a force on a deformable type of body, the body will get deformed, and prevent this deformation, internal resisting force is to be developed. So internal resisting force is to be developed, the result is become stress is to be developed. If body is not tends to be deformed, then why internal resisting forces develop unnecessary? Please give me an answer. Which come first? Stress is first, stress come first, or strain will come first? Now please give me an answer. Stress will come first or strain will first? My dear friends, without deformation, internal resisting force is not to be developed. Why internal resisting forces develop? Actually, internal resisting force develop to prevent the deformation. Are you get my point? So write down a very, very important statement. Strain is a cause of stress. Strain is a cause of stress. Not stress is a cause of strain. Strain is a cause of stress. I will say strain is a cause of stress. So I will say strain is a cause of stress. Strain is a cause of stress. Strain will come first. After that, stress will develop. Strain will come first. After that, stress is to be developed. Strain will come first. After that, stress is to be developed. So we can write like strain is a more basic parameter. We can write strain is a more basic parameter as compared to strain is a more basic parameter as compared to stress. So I will say strain is a more basic parameter as compared to stress. Strain is a more basic parameter as compared to stress. My dear friends, now see here what actually I will discuss. So now I will discuss stress strain curve. Stress strain curve of steel. Stress strain curve of steel. Now see here. Now what do you mean about stress strain curve of steel? Now see, if I am talking about the steel, so in general terms we can say steel is an alloy of iron and carbon. In general terms, if I am talking about steel, steel that means, in general terms, if I am talking about the steel here, so steel that means steel is a alloy Steel is a alloy of iron and carbon. Steel is an alloy of iron and carbon. So steel is an alloy of iron and carbon. In simple word, we can say steel is an alloy of iron and carbon. Steel is an alloy of iron and carbon. Simple terms, steel is an alloy of iron and carbon. We already know that iron is a natural material. It's not a man-made material. Am I right? Iron is a Devraj, yes, we will discuss mild steel after that. We will discuss mild steel after that because what is mild steel? Firstly, I am interested to introduce what do you mean about iron? What do you mean about steel? If you know the steel, if you know about the iron, then we will go to the mild steel. If I directly jump it, then the concept will not completely understand properly. Are you get my point? So, my dear friends, steel is an alloy of iron and carbon. Steel is an alloy of iron and carbon. So, suppose that if I am talking about you belongs from Manipur, na? All of these are belongs to Manipur, na? Manipur. Okay. So, what is your state language? What's your state language? Manipuri is your state language. Okay. Then, not able to understand Hindi. You all are. We can understand. Okay, you can understand. So, how many number of students are not able to understand Hindi? How many number of students are not able? English is better. So, yes, English is better. There is no problem. But in general language, I will ask how many number of students are not understand Hindi? Okay, so the majority is in English language. I can't understand. Okay, you can't understand. It's okay, there is no problem. So if I'm talking about the steel is an alloy of iron and carbon. If I'm talking about the steel here, so steel is a alloy of iron and carbon. We already know that iron is a natural material. It's not a man-made material. If I'm talking about the iron, so iron is a natural material. If I'm talking about iron here, so iron is a natural material. I am talking about iron, so iron is a natural material. Iron is a natural material. It's not a man-made material. But but if I'm talking about the iron, I can understand any language. Okay, sir. So if I'm talking about iron, so iron is a natural material, I will say. If I'm talking about the iron, so iron is a natural material. But in mines, iron is in form of stones. But in mines, if I'm actually iron is explored in mines now. Mines. So in mines, iron generally a form of stones. And this stone is attracted by the magnet. If this stone is attracted by the magnet, that means in this particular stone, ferrous is present. Due to this ferrous, the symbolic representation of iron is Fe. Due to this presence of ferrous, the symbolic representation of iron is Fe. Are you get my point? But the but in mines, naturally steel in form of stones. And this is the impurest form of iron. This is the impurest form of iron because stone is not directly used in a production unit or any other construction. Am I right? So this is the impurest form of iron. So my dear friend, the impurest form of iron, if I am talking about impurest form of iron, it is called as pig iron. It is called pig iron. So the first question is, what is the impurest form of iron? So impurest form of iron is pig iron. Second statement is impurest form of iron. Impurest form of iron. Impurest form of iron is called pig iron. Impurest form of iron is called pig iron. Is called pig iron. Now, this iron is pured in production units. This iron is pured in production unit. It will be pure in production unit. If this iron will be pure in production unit, this iron, this iron will be pure in production unit. So the purest form of iron after pure this pig iron, the purest form of iron will form, and this purest form of iron is called wrought iron. So purest form of iron. So purest form of iron is called wrought iron. Purest form of iron is called wrought iron. The purest form of iron is called wrought iron. Purest form of iron is called wrought iron. So I will say, impurest form of iron is called pig iron, and the purest form of iron is called wrought iron. My dear friends, if I am talking about, this is the rod of wrought iron. I am talking about, this is a rod of wrought iron. This is a rod of wrought iron. And you are putting this rod on UTM. You know UTM? You know UTM? This rod is putting on UTM. This rod is putting on UTM. What do you mean about UTM? UTM, that means universal testing machine. Are you get my point? If I am talking about the UTM, UTM, that means universal testing machine. So universal testing machine, it is said to be a UTM. It is said to be a UTM. So if I am talking about UTM, that means universal testing machine. It is UTM, universal testing machine. So I will considering a rod of wrought iron. A rod of wrought iron. Wrought iron is the purest form of iron, and pig iron is the impurest form of iron. So if I am talking about the if I am taking about the rod of pig iron, if I am taking about the rod of wrought iron, and you are applying this rod is put on a UTM and applying a tensile force over there. If you are applying a tensile force over there, the stress strain curve will develop of wrought iron. The stress strain curve of wrought iron will develop. So if I will draw the stress strain curve, then always we remember one point: strain is a more basic parameter or independent parameter. It will come first. Am I right? In the previous slide, I already discussed this particular point. So my dear friend, the strain is a more basic parameter as compared to stress. If strain is a more basic parameter as compared to stress, that means if you draw the stress strain curve of any type of steel or concrete or any material, if you draw the stress strain curve. So if you draw the stress strain curve of any type of steel, then strain is plotted on x-axis, then strain is plotted on x-axis, and stress is plotted on y-axis. So I will say then strain is plotted on x-axis and stress is plotted on y-axis. Strain is plotted on x-axis and stress always is plotted on y-axis. The reason is because strain is a more basic parameter as compared to stress, because strain is a more basic parameter as compared to stress. My dear friends, if the rod of wrought iron is put on a UTM, if the rod of wrought iron is put on the UTM and applying a force on this particular bar, tensile force on this particular bar, but remember one point, the force is gradually vary, not suddenly applied. Are you get my point? The force is gradually vary, not suddenly applied. The force is gradually vary, it's not suddenly applied, I will say. So, my dear friends, the force is gradually vary, not suddenly applied. The condition is this, if you are applying a force and if you are applying a gradually force by on a wrought iron rod or wrought iron specimen, the stress strain curve like this. This is the stress strain curve of wrought iron. So, if I am talking about, this is the stress strain curve of which iron? It is a wrought iron. If I am talking about wrought iron, the carbon content of this particular wrought iron is lesser than 0.10%. So I will say the carbon content of the wrought iron, is lesser than 0.10%. If I am talking about this particular iron, so we observe that the value of strain is very high, but the value of stress is very low. The value of strain is very high. That means if you are applying the force, the wrought iron will get elongate without any failure. But the stress is very less. That means the value of the internal resisting force is very less if you are applying the small amount of loading. If internal resisting force is very less, that means if you are applying the small amount of loading, the body will get deformed after a small amount of loading also. Please give me an answer. This type of steel you can use in our construction. If you are applying a small force on this particular steel, the steel will get deformed. No. Yes, it is good thing. The strain is very high. That means it is enough ductile. But I want, if we are using the steel in a structure, then there will be a significant amount of internal resisting force. I never will take this type of steel in construction, because if you are applying the small amount of load this particular iron, then iron will get deformed. No, I am not interested. I am not interested to use this steel in structure, because yes, the good thing is significant amount of strain, but the bad thing is internal resisting force is very less. If internal resisting force is very less, that means if you are applying a small amount of loading in this particular iron, the iron will get deformed due to application of a small amount of loading. My dear friends, after so many researcher or engineers are found, carbon is only a mineral which influence the properties of steel. If you are changing the small percentage of carbon in the iron molecule, if you are changing the small amount of carbon in the iron molecule, then the property of steel will suddenly change. The property of steel will suddenly change, so engineers or researchers are increase the carbon content in wrought iron. If engineers and researchers are increase the carbon content in wrought iron, after increasing the carbon content, the new iron will form, and the stress strain curve of those iron like this. This is the stress strain curve of those iron. This is the stress strain curve of those iron. My dear friend, in this particular iron, if you are increasing the carbon content in wrought iron, because carbon is only a mineral which influence the properties of steel. If you are increasing the carbon content in wrought iron, then a new steel is to be formed, and this steel is said to be a cast iron. This steel is said to be a cast iron. In cast iron, carbon content is greater than 1.10%. In cast iron, the carbon content is greater than 1.10%. My dear friend, in this particular iron, if I am talking about this particular iron, so significant amount of stress, but strain is very less. That means a small amount of strain, after a small amount of strain, it will fail. That means, please give me answer. That means sudden failure will observe in cast iron. Please give me answer. This means sudden failure will observe in cast iron. It will take large amount of loading. But they fail a sudden. They will get sudden failure. This type of steel or this type of iron also not used in the structure. This type of iron is also not used in a structure. Yes, it is brittle in nature. It will take large amount of loading. If it will take large amount of loading, and suddenly it will fail. If it is suddenly it will fail. All the structure is become collapse suddenly. All the structure will collapse suddenly, and after sudden failure, there is no chance to move here to here. Suddenly the structure will collapse. We are going to. Are you get my point? So the accident is the risk of the accident is very high. Am I right? The risk of the accident is very high. We want this type of steel which gives significant amount of stress as well as significant amount of strain. In wrought iron, the value of significance amount significant amount of strain will observe, but stress will not observe. In cast iron, significant amount of stress will observe, but strain will not observe. Then engineer and researcher again do something. Dekhiye kya? So I will say, if you are increasing the carbon content in wrought iron and engineers or scientists or researchers are decreasing the carbon content in the cast iron, engineers are increase carbon content in wrought iron and decrease some carbon content in cast iron and make a steel, and the stress strain curve of this steel like this. And the stress strain curve of this steel like this. And this steel is said to be a mild steel. This steel is said to be a mild steel. The carbon content of this mild steel is greater or equal to 0.10% and less or equal to 1.10%. Please remember this point. The carbon content of the mild steel is greater or equal to 0.10% and less or equal to 1.10%. If I am talking about the mild steel, so you can see here, in mild steel, significant amount of strain like a wrought iron and significant amount of strain like a cast iron. Please give me answer. Can this steel can be used in construction purpose? Give me answer. This steel can be used for construction purpose. Answer is yes, yeah. Answer is yes, because it will give significant amount of stress like a wrought iron, like a cast iron, and significant amount of strain like a wrought iron. Yes, this steel can be used. Yes, this steel can be used. Yes, this steel can be used in construction purpose. This steel can be used in construction purpose. This steel can be used in construction purpose. So mild steel used as a construction purpose. The answer is because it gives significant amount of stress like a cast iron and significant amount of strain like a wrought iron. So write down the statement, please. I will say carbon is only a mineral. Carbon is only a mineral which influence carbon is only a mineral which influence the property of steel, which influence which influence the properties of steel. Carbon is only a mineral which influence the properties of steel. Next point लिखिएगा, mild steel used as a construction purpose. Mild steel used as a construction purpose. Mild steel used as a construction purpose because mild steel used as a construction purpose because it gives significant amount of strain like a wrought iron, because it gives significant amount of strain like a wrought iron and significant amount of stress like a cast iron and significant amount of stress like a cast iron. I get my point. So I will say mild steel used as a construction purpose because construction purpose, here put a because it gives significant amount of strain like a wrought iron and significant amount of stress like a cast iron. So the write down the heading of the next topic, that means stress strain curve of mild steel, because mild steel is used as a construction purpose. So firstly I am introduced stress strain curve of mild steel. If I am talking about stress strain curve of mild steel, so now see here, if we are talking about stress strain curve of mild steel, so if you are considering the stress strain curve of mild steel, you already know that if you draw the stress strain curve, then strain always be plotted on x-axis and stress always be plotted on y-axis, because strain is a more basic parameter as compared to stress. So those parameters which are more basic always be plotted on the x-axis. I get my point? Always be plotted on a x-axis. So if I am talking about the stress strain curve of mild steel, the shape of the stress strain curve of mild steel like this, but various points are to be observed on this particular curve: A, B, C, C dash, C dash, D, D, E, F, and F. These are the number of points which are observed on a mild steel stress strain curve. All the points having a different significance, and each and every point have a unique property also. You get my point? I think now today is Holi festival, so it's there will be some family time. I will take the class only for 1 hour from today. After from tomorrow, the class timing